Hi, welcome back. Today we're going to talk about section 3.4, which the heading is just other common functions, but we're going to look at just kind of the basic functions that you've used throughout your high school career in algebra, and then we're going to use these to kind of look at some ways that we can move these around and look at domain and just some different things about them. So on this first page, there's no notes to be taken. These are just what we call the parent functions, okay? And it says at the top that you must know these functions and the shape. Okay? Now, granted, you have your calculators, so, if you forget kind of what one looks like, that's okay. But you want to make sure that you can sort of recognize them when you're doing problems. It will help you out. So also on this page, you have the domain and the range for each of these parent functions. And then you also have the end behaviors. Okay, we'll talk more about end behaviors as we move through this chapter and the next chapter. So just kind of keep that in mind. Okay? All right, so let's kind of talk about the functions that you're responsible for. So we have linear functions, which is the first one. Okay, y equals mx plus b. This is just y equals x. So again, that's the parent function. When you start putting the y-intercepts on there, then that moves that graph around. On the right, you have the absolute value of x, which the shape is a v. Then you have quadratic equations, which we all know the shape of that is a u. We have radical functions, so that's the shape of a square root function. We have cubic functions, so y equals x cubed. Cube root functions, exponential functions, logarithmic functions, and then two types of rational functions. There's rational inverse, and then there's rational with inverse squared. And then I don't do a whole lot with the bottom one here, this integer function, but the greatest integer function is one that you may have worked with. Okay? So, and then the last one is just your constant function, which is just a horizontal line at y equals any number. Okay. All right. So we're going to get started on answering some of these questions. So let's look at that, and then we can go back to our general shape if we need to. All right, so it says, given the function below, and by using your knowledge of the general shape of the graph, sketch the graph of the function by finding 2 or 3 points that satisfy this equation. Okay. All right. So the first one is absolute value, and then it's the absolute value of x minus 3. So if we take a look at that, I know that the shape is going to be a v, like the absolute value function. Okay. So what I would say is use some points. Now you can go to your table on your calculator, but let's see what happens to this, because I know the absolute value of x, okay, the parent function is here. So if the parent function is there, this is going to do something to that graph. And hopefully you guys remember a little bit about transformations, which we'll actually do in the next section. Okay? But this shifts the graph left and right. That's what's going to happen. So we're going to pick some numbers. Let's pick a couple of negative and a couple positive. So let's just do -2, -1, 0, 1, and 2. And let's see what happens. So if we put a -2 in here for x, we get -2 minus 3, which is -5. The absolute value of -5 is +5. We put a -1 in here. Okay, -1 minus 3 is -4. Absolute value of that is +4. Put a 0 in there. 0 minus 3 is -3. Absolute value of -3 is 3. Put a 1 in there. 1 minus 3 is -2. That absolute value would be 2. And put a 2 in there. 2 minus 3 is -1. Absolute value of that is 1. Okay? All right, so if we look at all those, -2, 5, -1, 4, 0, 3, 1, 2, and 2, 1, you'll see we're getting the back side of that v, but it's moving it over. So let's pick a few more numbers. 3, 4. So if I put 3 in there, 3 minus 3 is 0. Absolute value of 0 is 0. So now I'm at the point. And if I put 4 in there, 4 minus 3 is 1. Absolute value of 1 is 1. And you'll see you'll start going up. So now I know that this graph's going to continue this way. So here's my graph of my absolute value function. Okay. So notice what happened. It got shifted to the right 3. Okay. So notice that inside, because we're going to again talk about this as we go through our transformation section in the next section actually. All right, now, so keep in mind that we went right 3. We moved over to the right 3 when we had something inside the absolute value. Now let's look at our square root function, number 2. Well, I know the square root function, the general curve of it is over here. Right? It goes that way. That's the parent function. So this says take the square root of x and add 2 to it. Okay. All right. Now, with square roots, remember we can't have the square root of a negative number. So we need to make sure that we pick numbers bigger than or equal to 0. So let's just do 0, 1, 2. No, let's not do 2. Let's do 0, 1, and 4. I want to be able to take the square root without using my calculator, so we'll do 4. All right, so put in 0 for x. Square root of 0, 0, plus 2 is 2. Put in 1 for x. Square root of 1 is 1, plus 2 is 3. And put in 4 for x. The square root of 4 is 2. 2 plus 2 is 4. All right, so now if we plot 0, 2, 1, 3, and 4, 1, 2, 3, 4. Okay, here's our new graph, the one they asked us to graph. So what happened to the parent function? We went up 2. Everything went up 2 units. So that's that 2 there at the end. So I'm trying to remind you about transformations, even though that's not what we're doing right now, but that is what's happening to this curve. Okay? All right. So number 3 is a cube problem. So remember the parent function for cube kind of looks like this. Okay? Just goes through the origin and has that curve to it. And we're going to take 1/2 of x cubed. Okay, so we need to pick, doesn't really matter. Let's do a couple positive and a couple negative. So let's do -2, -1, 0, 1, 2 again. See what happens with that. All right, so -2. If you put -2 in for x, you have to cube it first, which will give you a -8. Then you take half of -8, which is -4. Take -1 and cube it, you get -1. Take 1/2 of that, you get -1/2. 0 cubed is 0 times 1/2 is 0. Put 1 in there, 1 cubed is 1, half of 1 is 1/2. And put 2 in there again, 2 cubed is 8, half of 8 is 4. All right, so if we look at this graph, -2, -4, 3, 4, -1, -1/2, 0, 0, 1, 1/2, and 2, 4. All right, so you notice it didn't change that much. Okay? All right. So that 1/2 out there basically is going to take your graph and make it a little bit fatter. So I kind of sketched the other one. The other one is kind of in here a little bit. So it just made it kind of stretch out a little bit more. Okay? So not a whole lot of excitement with that one. All right, and then down at the bottom we have the rational function. Okay, so these I'm going to put in my calculator real quick because I know we haven't done these much and we're going to spend a whole chapter on rational functions. So I want to just kind of make sure when you work with these, you can put them in your calculator to kind of help you out if you're having any of these questions on Hawks. So I want to remind you, when you go to y equals and try to graph a rational function, 3 divided by, you have to put, if there's more than one thing in the numerator or denominator, in parentheses. So I would have to put x minus 1 in parentheses, otherwise you're going to get the wrong graph. Okay, so I just want to remind you of that. So notice I did 3 divided by, and then I put that in parentheses. So now when I graph it, I'll see this rational function and kind of where it goes. Okay, so you can use this to help you out with your table as well, with your points. So let's say I want to go to the table and get these values. So I see that I have, if you remember, asymptotes. So I can't use 1 in this problem. Right? The domain of this would be x can't be 1. So when you graph it, I know that at 1, I'm going to put as best I can a dotted line here. That's an asymptote. So we can't use 1. 1 is not allowed in that problem. But there are numbers to the left of 1 I can use and to the right of 1. So if you go to your table, which is second graph, then you can grab some ordered pairs and plot them. Okay, so let's do whole numbers. So -2, -1 is a point. And then also I'll use 0, -3. And then let's get some points on the other side. So 2, 3. And maybe 4, 1. Okay. That's enough to kind of see where the points are going to end up. So -2, -1. And 0, -3. And that's enough to kind of do this, so I know that that's where the graph goes. Remember, you're just sketching, so it's okay. When you're on Hawks, you'll get to pick the points, so it'll be a little bit easier. And then 2, 3. And 4, 1. And that'll give you that side of the graph. Okay? So again, I'm doing it kind of quickly and sketching it. I don't believe this arrow probably needs to be underneath the x-axis. I drew it a little bit high. It probably does not cross the x-axis there. Okay? But that's the shape. So I just wanted to show you can use your table and use your calculator. I am perfectly fine with that. All right. Let's move on to piecewise functions now. So now we have a glimpse of all those functions on the other page. So now we're going to graph what we call piecewise functions, which is to take pieces of the function and graph them. So if you look at number 5, we're going to take x squared, which is a parabola, and we're only going to use it when our x values are less than 1. And then we're going to also take 1 minus x, which is a line, and we're going to graph that when x is greater than or equal to 1. So here's a nice way I can show you how to do this so that you can kind of guarantee the right answer. So we're going to start with the top function, y equals x squared. And we're going to pick some points based on what's given to us. So you always use the boundary point, okay? X is less than 1, so we're going to start with 1. But since it's less than 1, I'm going to put an open circle here because when I go to graph it, I know that this is not really included, but I need that point because that's my starting point. And then numbers less than 1 would be 0, -1, -2, and then we keep going. So I'm going to put an arrow here. Again, when I graph, that tells me that I can keep going as far as I want to go. Okay? All right, so here's x and y. So let's put these numbers into x squared. So 1 squared is 1, 0 squared is 0, -1 squared is 1, and -2 squared is a positive 4. All right, so now when I graph that, 1, 1, I'm going to put an open circle, 0, 0, -1, 1, -2, 4. So this parabola is going to continue that way, okay? Because I can keep going after -2. All right, now I'm going to do the same thing with the second function, which is y equals -x plus 1. I'm going to write it that way because that's the slope-intercept form. You don't have to. Okay, but I'm going to pick numbers greater than or equal to 1. So 1, which is a closed circle, and then numbers greater than that, 2, 1, 2, 3. Now, I'm going to go greater, so again, that's going to be an arrow on that side because I can keep going. Okay? All right, so we're going to plug in these numbers. So -1 plus 1 is 0. -2 plus 1 is -1. -3 plus 1 is -2. Okay, so plot those points. So now, 1, 0 is here, closed circle. 2, -1. 3, -2. So that's going to go this way, and it's going to keep going in that direction. Okay? It's not a very good straight line, but that's a straight line that goes to the right. So we used the parabola and we used the line, and it wasn't too hard to sketch if we just kind of follow those rules, okay? So we're going to try that again with 3 graphs this time, 3 piecewise on number 6. All right, so if you look at number 6, we're going to use x squared when x is less than 0. We're just going to use 2 when x equals 0. And we're going to use the square root of x when x is greater than 0. All right, so again, we're going to do 3 graphs. We're going to start with x squared. We're going to get our table. We're going to start with this number. X is less than 0. Numbers less than 0, right? -1, -2. They're going to keep going down there, and I'm not using that first number, so that's going to be an open circle. Plug in those numbers into x squared. 0 squared is 0, -1 squared is 1, and -2 squared is 4. So we're going to plot those points. There's an open circle, and then again that parabola. So we got a curve. It goes that way. Okay? Now look at the second one, y equals 2. And we're only going to use y equals 2 when x is 0. Okay? It's equal to 0. Well, if x is 0, it doesn't matter. Y is going to be 2. That's what that says. So we're going to plot the point 0, 2. And that one we're using because it's equal to it, right? I'm sorry this is shaking so bad. I'm using a table and it's not very sturdy, so I apologize for that. All right, and then the last one is the square root of x. Okay, so again, we're going to use the table. We're going to use numbers greater than 0, 0, 1, no, did that again. Let's use 0, 1, 4. So we can take the square root. Now, greater than 0, so we're not using it. And then we're going to keep going greater than that way. All right, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So now look at what happens. I'm not plotting 0, 0, but it's still right here. So there's my open circle. And then I've got 1, 1, and 4, 2. And remember the shape of a square root function goes like that. Okay, so there's your piecewise function. Okay, so no matter how many you have, that's how you can graph them, and it works out pretty nicely if you kind of just follow those steps in order to graph. All right, let's look at the next one on the next page. Another piecewise function. So we're going to sketch the graph. Okay, sketch the graph. So, a couple of things. We got 3 functions, so let's start with the first function. Y equals 1. So that's just y is 1 no matter what x is. So let's pick some x's. We're going to use numbers less than -1. So we're going to start with -1, open circle. Less than would be -2, -3. Doesn't matter what x is, y is 1. Right? So we're going to, doesn't matter. So we're going to put an open circle at -1, 1. And this is going to keep going. I forgot to draw that, but I'm going to keep going. Any number less than -1 will work. So that's going to be here, here. So it's just going to go this way. Okay, horizontal line. All right, now we're going to do the cube root. All right, x and y. And we're only going to pick numbers between -1 and 0. That's it. So -1, 0. I'm going to use -1. And I'm not going to use 0. I can't use 0. So the cube root of -1 is -1. And the cube root of 0 is 0. So at -1, -1, I'm going to put a closed circle. At 0, 0, it's an open circle, and not much there. Okay, just that little bit. And lastly, we're going to use 1 over x. That's that rational function. You remember what it looked like? We just put it in our calculator a little while ago. A little bit different, but just 1 over x. And we're going to use that when x is greater than 0. So let's do 0, 1, and 2. And greater than would be an open circle there. And we're going to keep going after 2. All right, so remember, 1 over 0 is undefined. There's no solution there. So remember, that's an asymptote. So at 0 now, we can't use that. All right, then we've got put 1 in there. 1 over 1 is 1. And put 2 in there. 1 over 2 is 1/2. So we have 1, 1, 1. Okay. 1, and then 2, 1/2. So if you remember what this looks like, it kind of gets close, right? And then it goes this way. So there's that part of that rational function. All right, so there's that graph. So now we're going to answer some questions. B says evaluate f of -3, f of -1, and f of 2. So this just means we got to go to which one of the three equations that fit this x value. All right, so we'll start with f is -3. Well, -3 is less than -1, so I'm going to use this equation, which the answer is just 1. Okay. Then I'm going to do f of -1. Well, -1 is not less than -1, it's equal to it. So now I'm going to use this equation. So I'm going to put -1 in here. So I'm going to do the cube root of -1, which is -1. And lastly, I'm going to do f of 2. Well, 2 is definitely greater than 0, so I'm going to put it in here. So that would be 1 over 2, which is 1/2. Now, you could get the values from here as well, but I just want you to get used to this because you're not always going to graph. You may just have this to answer those function questions, okay? All right, part C, determine the domain and the range. All right, so let's look at our problem. So if you look at your graph, your domain, since you have an arrow here, is going to start at -infinity. The end of your domain, because there's an arrow here, will be +infinity. And you're using every single number in here, except remember that you can't use 0. Remember this right here? So you have to take 0 out of the domain. You're not allowed to use 0 here. Even though you can use it in other places, you can't use it here. So that means our domain would be all real numbers except for 0. So we would write -infinity to 0, and then 0 to infinity. Remember, that's how you write all real numbers except for 0. Okay? Now the range, you got to look at the graph. So I use numbers on, now we're looking at y for the range. So I use numbers between -1 and 0, not including 0. And then as soon as I go above 0, I used everything else. And again, this arrow means I'm going to +infinity on the y-axis. So I'm going to do my range as -1, including it, to 0, not including 0, and then from 0 to infinity. Okay, so again, look at that for your y's. I'm using the y's in here. That's between -1 and 0. And then I'm using all the y's above 0. Okay, so there's your range. All right, number 8. Write a function for the piecewise function below, then state the domain and the range. All right, well, they're giving you these equations just to help you out. So let's see if we can write it. So we know we got 3 equations. So we would have space for 3 things. And always start on the left. So we're going to start with x squared. And you don't have to write y equals, because remember, this is the y equals. So you're just writing what's on the right side of those equal signs. Then we're going to do 6, and then we're going to do 10 minus x. So they're giving us those, right? And now we have to say when we're using the x's. When do we use these graphs? So remember up here, it's kind of what I'm doing. So I've got the equations, and now I'm going to say when I'm using them. All right, so when am I using this equation? Well, this is 1, 2, 3, 4, 5, 6. All right, so we're starting y equals x squared at x equals 2, not including 2, but then everything to the left of it. So that would be when x is less than 2, okay? Y equals 6 is just that dot. So we're only using y equals 6 when x equals 2. Then we're going to use the line y equals 10 minus x only between these two numbers. So from 2 to 6, not including 2, but including 6. So it would look like that. Okay? So there would be the piecewise function that would give us this graph. Now the domain, again, that arrow means I'm going to -infinity for the x value, and I'm going to go all the way I'm not stopping at 2 because I'm using 2, and I'm using all the numbers till I get to 6. So the domain would go from negative infinity to 6, and I would include 6. Okay. I don't have to stop at 2. Some of you would stop at 2 and then keep going at 2, but you're using 2, right? That's the point, 2, 6. So you are using x equals 2, so you don't need to stop at 2. All right, the range, the y values don't go anywhere less than 0, right? That's 0, 0. And then I'm going to keep going up, and again, that arrow means I'm going to go up forever. And I'm using every number in between, so there's no breaks in y. Even though there's a hole there, I'm using it here, so I don't have to stop. So the range is going to go from 0 to positive infinity, okay, from 0 up. All right, so I'm going to stop. This will be part 1 for this section, and then I'm going to finish up on the next video, just because, again, I don't want this to run too long. We won't have too much farther to go, but I like to try to stop these within 30 minutes. So you can work on some homework, or you can continue to part 2 of your video, whichever you prefer. So see you back here in a little bit.